I would like to next give a very warm welcome to Anne from Ramboll.
Ooh. This one?
Yep.
Okay. Hello. So I am Anne from Ramboll, and I am the technical area manager for BIM and digitalization for Ramboll Sweden. I was pretty excited to see that there were quite a few of my colleagues that I need to talk to in Copenhagen. I was thinking to talk to you a little bit about some of the digital tools we use for BIM within Ramboll throughout the design process to hopefully come out with a more sustainable product at the end. I think everyone's familiar with the kind of standard, old school, linear, relatively linear design process, and hopefully understands, where BIM comes into it, that it's a bit cyclical. So at each stage of the process, you have more information, more data, you put it into your project, you put it into your model, you make some assessments from that data, then you make decisions from those assessments, and then you put more data in. And then it repeats throughout the design process with the information that you're tracking and managing growing exponentially. So obviously, I don't have to talk to you about sustainability. You wouldn't be here if you didn't care about it. But like some of the others have mentioned before, I think two of the other speakers, at Ramboll, we're also part of the UN Global Compact and have been since 2007. But in addition to our personal and then sort of company sustainability goals globally, we're generally working at a local level with projects. And hopefully, and it's happening more and more, when your client comes to you with a brief, they come with a sustainable ask. They want to have a sustainable project, whether it's just general sustainability or if they're going for some kind of certification, whether that's LEED, BREEAM, Swedish Green Building Council. And so hopefully at the beginning of a project, you set up your goals, whatever they are. And then you have to work towards those goals. But one of the problems you face is that you can't assess whether you've met those goals usually until you're quite far into a project. So detailed design or construction design phase. And that means you're having to plan several steps ahead. And with the size of the projects that we sometimes have, that could be years ahead. So you're going to have to plan for the data you know you need, the data you think you need, the level of detail you're going to need in your model, and a number of other factors. You're going to have to look at the tools that you need, the tools that exist, or are there tools that don't exist that you need and you need to develop? But hopefully, if you plan correctly and gather your data and manage it well throughout the process, you'll come out with a better product. So now this is the fun part. These are the tools. So I'm going to give you a preview of a couple of tools that we have developed and use in-house. But I can say that there are similar tools happening at most of the other large consulting companies. And of course, more and more third-party plugins and applications hitting the market because sustainability is a goal that we all have, but it's also a business opportunity. So this is one of the tools that we use. You can either load in a model and do calculations based on it, or, as you're seeing here, you can, with the data you know about your local site, you can then begin to produce options that should meet the parameters you've put in. I haven't tried it that far, but I assume the options are almost exponential. And here's the best part, and here's where the sustainability comes into play. You can very quickly start to check some sustainability factors. Your daylighting, your overshadowing of neighbors, things like that. And this is one of the diagrams that you can export very quickly, easily, with just a mass, whether it's one you've loaded in or one you've allowed the program to help you choose. And this shows wind velocity and wind comfort at the ground level for pedestrians, which is one of the check boxes, I guess you would say, in a number of the sustainability certifications that you might be going for. And it can also be a real problem if you don't run this until later on in the project. So what can you check for very early on with tools like this? You can check livability, like daylight on the facades, overshadowing of external spaces. You can do view analysis to make sure you're not blocking your best views. You can, and this is also a big money saver because it can cause a lot of problems if you don't catch it early, is you can do some environmental checks. You can do early risk analysis for wind comfort, like we saw, and for acoustics. But you can also do some other things that can be real problems later on in construction documentation if you've forgotten to look at them earlier. Logistical problems like optimizing car and bike parking, travel distances across the site, how emergency, fire, and refuse vehicles are going to access the site. So now, at this point, hopefully we have the outline of our building, and we're moving forward and making design decisions about the structure and the materials, and putting more and more data into the model. And we have to keep checking whether or not we're meeting our sustainability goals. So the next tool that we often use, it's relatively new, but we're using it on a number of projects now. Only one in Sweden, soon to be two, where we're doing life cycle CO2 analysis. And just like the previous tool, you can either load in your model and do the assessments from the information in your model and the materials in your model, but you can also use it very early on to make early decisions. You can look at a variety of different materials and get life cycle analysis on them and see which material, not just initially, but over the life cycle, is actually a more sustainable choice. So we already know that the building industry is a big CO2 emitter, but actually 90% of the building industry on site is materials, the CO2 emissions. So making smart choices about materials early on is something we need to be thinking about. So this is an example of a project where we're looking at a brick facade, a metal facade, and a wood facade. And we're able to very quickly, with the size of the project, because we know all of that, have a very quick analysis of the whole CO2 life cycle, and hopefully make good decisions. And hopefully we've made good decisions, we've documented them, we've used all the tools in our arsenal to prove and reprove and adjust, and we can now check whether or not we've met our sustainability goals that we set at the beginning, and get any certification we're after. But it doesn't end there, because the advantage of BIM is that sustainability assessments should continue. You should track and evaluate the success of the building after it is operational, because the building of the building is such a small part of the, hopefully, a small part of the life cycle of a building. So this is a quick little data visualization that a colleague of mine did a week or two ago for a client as a mock-up. She was your original speaker, and I've replaced her because she had to go to Berlin to work on the Tesla Gigafactory ASAP. So, so this is a building where we had the BIM model, and we had real data from the sensors, the temperature sensors inside the building, and then we're very quickly able to look at, say, ventilation in a summer month. So we're able to look at, say, July, and very quickly we find out, yes, we have a problem. We have some underventilation recorded, but we also have a problem that the purple circles with the crosses, we have no data. We don't have enough sensors. And then this is the big buzzword, digital twin. And if you'll forgive the non-sustainable example, this is something Ramboll has been using for 24 years in the oil and gas industry, specifically offshore rigs. And just to go over it quickly, for those of you who are maybe less familiar, in this example, what happens is a digital model is updated with real-time data of loads that are affecting the structure, which in the case of an oil rig is gonna basically be weather, wind, corrosion, waves. And from that information, you can then decide when your maintenance is going to happen. It can be on time, just in time, so you're not doing extra maintenance. So you're saving time and money, and it's also quite unsafe for some of the maintenance they have to do. It's quite dangerous. But you can also get ahead of any possible failures or anything you need to fix very quickly. And then hopefully you have a longer life cycle for the structure. So now actually we're using it on wind farms better. And we're now moving from wind farms, which we've done several of, into using it in the building industry. So hopefully that was interesting for y'all. There are quite a few other tools we use, but that was just a quick overview. We also can look at optimizing structural placement. And we can look at, of course, recycled and recycled content materials. And the hope is that eventually we can put all of these tools together into one offering. But if you've done your planning right, and you've used your tools, and you've used all of the optimization tools, as well as all of the traditional methods, of course. I'm an architect, so I don't think architects are obsolete just yet. And then you manage and track your data throughout the process, the design process, and beyond. The hope is that you can and will produce more and more sustainable projects. So thank you very much for having me. And if you're interested or you want to collaborate, please do feel free to get in touch.